big hurdles for especially for RNA therapies is to get the RNA into the right cells safely and effectively. And that's quite a challenge. First off, because RNA itself is very vulnerable to degradation. So once you put it inside the body then says, oh, don't like it here, it's out to get it, and it starts to attack it straight away. So it does need some element of protection and stability. Let's assume though you can protect it. You then got to get it into the cell. So the next challenge is getting it across the membrane of the cell wall. And the issue there is that the cell is negative and the RNA is negative. And imagine it's like two polar opposites. One way, they bounce off each other. So it's really difficult to get through. So what people end up doing is putting a huge amount in because only a tiny amount gets into the cell. So what you then need is need a delivery system to get it in. But once you've got it in, you then have another challenge, which is it's in the endosome of the cell and it needs to escape from the endosome and go into the cytoplasm. Because until it can get into the cytoplasm, then it can't produce the protein in the case of mRNA or knock down the protein in the case of siRNA. Another aspect of problem that these hurdles for these systems is targeting. If you just put RNA in, it'll just go all over the body. So you need to be able to target specific cells. And what we have today, primarily, we have things that target the liver. And that's because the delivery systems that are out there just go to the liver. But what you want is you want to be able to target a specific cell because you don't want to be turning off the RNA production in good cells around the body. You want to be just focusing on the ones where it's going wrong. So one of the potential side effects of these treatments is you can stop your body doing things that it should be doing while you're trying to address the things that it shouldn't be doing. Another thing is that they're all injectable at the moment, and that's because it's very difficult to actually get it into an oral application to protect it sufficiently. So you can put it into an oral application, get it through the gut wall and into the stomach and into the gut. And two reasons there. One, the lipid systems that people currently use, they're lipid by nature. And those fatty acid problems that get broken down when they get into the gut, so they won't protect the payload at all. And the second delivery system that most people use are viral vectors. And the problem with these is they're very toxic and they cause a lot of unwanted side effect issues once they get delivered into the gut. Solve those two issues and you can start looking at oral delivery, which means there's far more application for these RNA therapies than just injectables. So there's actually a significant unmet need for a better RNA delivery platform, one that is targeted to specific cells, that both non-toxic and effective, and it's easily manufactured.